All right, so as we look at problem 7.2, problem 7.2, we are going to be walking through the process. The first part will be very similar, but what we're going to use to specify our drive, which includes the input sprocket, the output sprocket, and the belt, okay? All three of those items get specified using a vendor's catalog, and Gates is going to be the vendor that we're going to be using. So we're going to follow this process, but we're going to deviate from how we finish it up, if you would. So it says we want to design a V-belt drive that has an input sheave on the shaft of an electric motor, normal torque, rated at 50 horsepower at 1160 RPM, full load speed. The drive is to be for a bucket elevator in a potash plant that is to be used 12 hours daily at approximately 6.75 RPM. So this is our output. This is our input. Okay. So we are going to be determining, like I said earlier, the sheave on the input, the sheave on the output, and the belt that's going to go over the top. Now, one distinct piece of information that's missing here is we don't have a center distance, which you would know in any application that you'd be specifying. So when we get to that point where we need a center distance, we're just going to pick one. Okay, that's going to be reasonable. All right. So what we're going to do is we're going to shift gears now, and we're going to look at the Gates catalog. So if you pulled that up, that PDF, kind of go over here, and I will open it up. Okay. You'll notice that it's 324 pages. So I'm not going to try to scroll through here and look at all the pages, but I'll tell you what pages we are on, and I'll let you catch up so that you can be sure to find the information. So, so where we're going to start here, it's kind of at the beginning. It's just kind of going over things. And the first page we're going to be looking at is going to be section A. We're going to be using heavy duty V-belt drives. Now, maybe I'm old school, but I like just a regular catalog, but everything is online. So I wanted to kind of transition to using the PDF that's here. But this is just giving us an idea of the belts that they have available. The belt that we're going to be sticking in is going to be the Super HC V belt. Oopsie. Super HC V belt. Okay. And then there's some other ones here, some molded and notched. They have some power band belts and such, but we're going to kind of keep it to kind of the entry level, if you would. Now, as we go down here, they're going to have some more belts that they can deal with. But then our next page, which is going to be page A4, this just kind of gives us the cross section and the construction of each one of these types of belts. Okay, so because we're going to be a Super HC V belt, that's what we're going to be looking at. You'll notice that they have three sizes in that series. They have a 3V, they have a 5V, and they have an 8V. Okay, and then they kind of highlight the construction that they have here. Then you'll notice that they do that very same thing for the same type of belt, but this one is the molded notched. Again, not for a synchronous drive. This would be for, making a smaller radius. Now you're going to continue, and you're going to notice that they do this for all the different types of cross sections that they have. Okay, all the different types. Now, I am going to stop there because I can see that it's not wanting to load. So I'm just going to close this application. I'm going to go back, and I am going to pull underneath now where we're going to actually start with the process. So if you go to page B, if you go to page B2, okay, you are going to find this page right here. So it's B2 is on the bottom left-hand corner. And you're going to find where it starts with in blue here, step 1. Step 1. So it says here, how do you select a correct V-belt and power band belt drive using stock sheaves and belts? And that's what we're aiming to use. Most often when you're designing out an industry, if you use stock items, they're going to be less expensive. They're going to be something that is readily available and that they make on a regular basis. If you go to anything custom, then you're going to be paying more. So we're going to be taking, if you would, off the shelf items and incorporating them into our design. So you'll notice here at the top here, it says before selecting a V-belt drive, you will need the following: the type, application, and the machine, and the work that's being done. We already kind of got that from our problem statement, okay? You also need to know what your horsepower rating is and the RPM of your driver. They capitalize the R and they capitalize the N. So we know that, you know, we're either the input or the output. The driver is going to be the input. The output is going to be the driven. And then the speed RPM for the driven machine. Now we've got an approximate number. Okay. So we're kind of stick around there, or the required speed ratio. And then you need an approximate center distance that's required. We're not given that. We will pick that when the time comes. Okay. We will pick that when the time comes. Now, over on the left-hand side, we're going to start with step number 1. Step number 1 says we want to find the design horsepower. Now, the design horsepower is going to be specific to the input and the output that we have going on here. So what we need to do is we need to go down to this table, B1, and we are going to be putting in and kind of determining what our service factor is going to be. Now our service factor, now I know this is very small for you to read. That's why I want you on the PDF version. And what we need to do is we need to find our driver. Okay, our driver is going to be our motor. I believe ours was identified as an electric motor normal torque. So we're right here, okay, in this column. So we're like right there. And then the other thing that it's asking us for up on the top here on this heading is intermittent service, normal service, or continuous service, okay? So in this case, what we need to do is we need to determine which one that is. So we've got to go back to our problem statement. Our problem statement said that we're going to be using it for approximately 12 hours a day. So when we look here, you'll notice that we go from 8 to 10 to 16. Okay. So you are the designer. You get to decide what is going to be the value that I use. Is it on a regular basis? Is it ever going to go over to 12 and then it's going to go closer to 16, or is it going to be, you know, on more close to 10? So it's up to you. All right. Some of these things aren't going to be cut and dry. You are the designer and you get to pick, and we'll talk about that in just a bit. Then we're going to line it up with the driven machine column down here. So we want to find, like, what is it called? A bucket elevator. A bucket elevator. See if you can find a bucket elevator anywhere here. And based on the application of potash plant, it seems kind of volatile. So it's probably going to be down towards the bottom-ish. And I do see a bucket elevator. I see it right here. Do you see that in this section? So now all we're going to do is we're going to line up in this area. We're going to pick a column, and then we're going to line up, you know, along that row. So we would either have a service factor of 1.3 or 1.5. Personally, I tend to be on the more conservative side of things. I would probably say, since we're 12 hours a day, that we would probably be more that continuous service as opposed to the normal service. Okay, it's just kind of tipping the scale. It's a little bit over. So our service factor then would be 1.5. Now, where do we put this? Let's look at our spreadsheet. Okay. Our spreadsheet is going to look just like it did, same kind of format as it was for our gears. So we're going to be using the C column, and we're going to be inputting wherever we see blues, and then we're going to let the spreadsheet calculate wherever we see these greenish colors. So as we look here, there's some information that was given to us in the problem. So first of all, the drive type. The drive type was an AC motor, right? And it was normal torque. So you can just fill that in. That's just kind of giving us information or filling in our givens. The driven machine is a bucket elevator. The service hours per day, we're going to put in 12. And notice that our units are on the right-hand side. The input speed of the driver. Okay, what was the input speed of the driver? 1160. 1160 RPM on the right. Our input horsepower. 50. And then our nominal output speed. Now, what happened here? Why am I think I hit run. There we go. I don't know what happened there. 50. There we go. I think I hit the button. And then what is our nominal output speed? Approximately 675, right? Yep, so that's there. And then the service factor, this is from table 1B on page B2. That's what you have here in the comments. So that's the one that we just looked at. So I'm gonna put 1.5. I'm the designer. So my horsepower, my design horsepower now is 75 horsepower. Okay, taking into consideration the actual application of the input to the output. Okay. Now, you'll notice that I line this up over on the right-hand side. We've got an extra column here. These are the gate steps. So this is step number 1, page 2B. We need to know what that design horsepower is. So you don't have to calculate it, but it just lines up with that step. Now what we're going to do is we're going to pick a cross section. This is step 2. So if I turn the page, I'm going to go back underneath my camera here. This is going to be our step 2. So I'm on page B3. Okay. Now what I want to do is I want to pick what is going to be an appropriate cross section that Gates has for my application. So I'm going to look down here. Again, I know these are really small, so they're going to be so much easier to read on your screen through the PDF. So the first one that I have here, this is the cross section, and you'll notice that we have these letters in the middle. These are going to correspond to standard cross sections they have for their belts. On the bottom here, this is going to be my design horsepower. So I'm going to go over until I find 75. Now this is 50, 60, 70, so a little bit past that. Now this is just to get us in an appropriate cross section. So it doesn't have to be super critical. So we're going to go up until we find 1160. So 1160 is coming across here. So I'm actually going to highlight this. Here's my 1160, 1160, 1160. Here's my 70, 75 right there. And they're intersecting right there. Okay. So you'll notice the section they're in is the 5VX or the 5V. Now it's kind of on the edge, but it's on the edge I want it to be on if I'm gonna be designing. So in this case, I do like to land in the middle, but if I don't necessarily want to be on the top edge of something, I'd rather be on the bottom edge. So you'll notice here that on 5VP, if I would be kind of down there, that would be really close to the upper level of what it can handle. So being in this one right here really puts it at the 5VX or the 5V. Okay. Now, if we go down to the bottom, this is another set of different belts. So these are different letters that we're going to see in here. And we can do that very same thing. We can take the 1160, go over, and we can find our 70, 75, go up. And you'll notice that here would be a BP. Okay. So just another option that would be appropriate. Okay. So I'm going to go with right now 5V or a 5VX. Okay. 5V or 5VX. Now the difference between these two is just going to be if we look, and you don't have to go back to this page, but we had looked at this page earlier. The 5V has the construction where it's just kind of a run-of-the-mill, no notched V belt, where the 5VX is notched. It offers you the ability to have a smaller sheave on the input because of those notches. That's the only difference between them. Okay. All right. Well, that's that. So that's our step number 2. So now what we're going to do is we're going to go back to our spreadsheet. And we are going to pick a cross section. Okay. For right now, we don't really know. Do I want a 5V or do I want a 5VX? I don't know. So I'm going to say 5V/5VX because that's really the area that we landed in. Okay. And again, the distinct difference is one is notched and one isn't. Now, with that information, you'll notice that it automatically calculated a couple things. It automatically calculated for us. It grabbed our input speed, it grabbed our output speed, and this is our nominal speed ratio. So this is like our velocity ratio, right? 1.719. Now what we're going to do is we're going to be actually picking an actual speed ratio. Okay. So on the right-hand side here, It says that we have to go to the charts for the V-belt cross sections, okay? Now, since we picked 5V, 5VX, we're gonna have to go to that section in the V-belt selection charts, the V-belt selection charts. And this starts us on step number 3. So if we turn the page, step number 3 is going to be on page 5B. Now, what I find kind of funny about Gates is they'll say 3 easy steps, but look at step number 3 has like 10 parts. Okay, that you have to do 10 different things. So there's still a process here, even though they say, oh, this is our final step. Okay, so we're gonna determine our we're gonna calculate our speed ratio, and we're gonna use that in the charts. So I'm gonna go back underneath, and you're gonna scroll ahead, and you're gonna find page B34, B35, and B36, B37. Okay, so B34 is where you want to start. So scroll ahead, and you're going to see pages that look like this. And at the top, you're going to notice you have your 5V, your 5VX, and then it's a 5VP. We're going to be getting one of these two, all right? Because that's the area that we hit. Everybody find that on the PDF? Okay. Now, you're going to notice on the left-hand side, okay? And I know you can't see my numbers here, but you're going to look at yours. On the left-hand side here, this column, this first column is sheave diameters or outside diameters, small and large. We're going to actually start with speed ratio. Okay, speed ratio. Our speed ratio from our Excel spreadsheet was 1.719 or 1.72-ish, right? So we're going to go back, and we're going to read down that speed ratio column, and we're going to see if we can find 1.72. Now I'm at 1.6, 1.72. So I see 1.72 right here. Okay. Now, as we look here at 1.72, you're going to notice that now page 34 and 35, I'm going to kind of pull mine out, and I'm going to show you what this looks like. Can I get any taller? If I would have the actual catalog in front of me, these two pages would be next to each other. So this would be 34 on my left. This would be 34 on my right. And I continue to read across. Okay. And then 36 and 37 are going to be the same thing. Now, as I look here, you're going to notice, and I'll zoom back in on page 34, that inside this area, these are the center distances, okay? So if I find 1.72 here, I've got two options, all right? If I go across on the bottom one, there are no center distances. If I go across on the top one, you're gonna notice that there is a sprocket that is really small, and there's a star by it, and it says that diameter is not recommended for some sizes, okay? So you wanna go on the one that doesn't have the star by it. So you're gonna be on the second one, but there isn't a center distance, isn't a center distance. And then we're going to keep going, and we're going to find that our center distances don't start until we're all the way over here, okay? And that's 16.3. Now, if we turn the page and we go to 36 and 37, so 36, as I said, is the first page when we open our catalog, and it matches up with 37. You're going to notice we find those very same numbers, the 1.72, but now we've got even more options for center distances, okay? It's just that the size of the sprockets don't accommodate center distances until we get to, what was that, like 15 inches, 16 inches, okay? And then now they're wider and wider and more options, and you can continue all the way across to the other side. Those are all your center distance options. So anywhere from about 15 inches all the way up to 154 inches. Okay. Right. Now we need to pick a center distance. Okay. So we're going to pick a center distance. That center distance is going to be, I'm picking it, 23.9. Okay, 23.9. So if we look here on our spreadsheet on page 36, we're going to look across that same line, and we're going to find the 23.9. It's right there. Now, again, on your PDF, you can zoom in, and you're going to have that ability to see this more clearly. So since that's my 23.9, that's the center distance I want, I'm going to go up to the top of the column, and right here is going to be the belts. That would be my options for that center distance. Okay, so I could go with a 5VX, and then it would be called a 950. I could go with a 5V 950, a 5VP 950, and they would all utilize small sprocket of 10.9, a large sprocket of, is that 18.7 or 16.7? 18.7. And then they are going to have a center distance of 23.9. And so the belt that I would order from them would be one of those 3 belts on top. Okay, so this eliminates us having to find what is the length of the belt that I need? What is the continuous length of the belt I need? Or calculating my center distance afterward. Do you see how they kind of did it all for us, and they determined what our sprockets were? Okay, done. So let's go back to our spreadsheet and kind of catch ourselves up with this information. So I'm going to go back over here. So our actual speed ratio. Because the catalog had 1.72, we're going to put that in. Sometimes it might not be as close as this one was. Sometimes you might have to make a choice between a couple of them, and you put it in here. And then what you're going to check is, okay, how close is my actual driven speed to what it was asking me to have in my problem? Okay. Now our problem said around 675. I think 674.42 is pretty good. That's approximate. Okay. Now I'm going to go down and I'm going to fill in my small sheave diameter. Okay, my small sheave diameter was 10.9. My large sheave diameter is 18.7. Okay. Now, before I go too far, I need to check these numbers on a table to make sure that I am not smaller than what the minimum is telling me that I can have. Now, it already kind of clued me in on that, but you always want to check it. So this is going to be, the minimum sizes are going to be found on B4. B4. So that means we're going to go back a little bit. And on B4, we're going to see this chart. Okay. This is minimum sheave diameters. Minimum sheave diameters. Now, the 5V and the 5VX are called Super HC V belts. Okay. So that means we're going to be looking at this one right here. And that would be from this right here, Super HC V belt. That was the category we kind of picked. So now we're going to look down here and we are going to find our motor horsepower, which is 50, not the 75. We're going to find the 50. And then we're going to find the output RPM. We're 1160. So we're going to go over to this column right here. And you'll notice that the minimum sheave is 8.2 inches. So our smaller sheave is 10.9. So we're fine. So you want to check that.
Is that I think it said motor RPM, so right?
Yep. So it's the motor RPM, the 1160. Did I say something different? And then 50 would be here. Yep. So where those two meet, 8.2 is going to be our minimum sheave diameter. So if we go back to our spreadsheet, 10.9 was our smaller, which is greater than the minimum. So we're good to continue to go forward. Now we're also going to input that center distance that we got off the chart, which was 23.9. Okay. And then we're going to put our V-belt number. So at the top of that column, we're going to go with I'm just going to, the 5V, which is the kind of run of the mill without the notches. I'm going to go with the 5V 950. 5V 950. And we'll call it out right here, 5V-950. Okay. All right. Now, horsepower correction factor. We have to go back to our chart where we picked our 23.9 center distance. And we are going to read the color chart at the bottom of the chart. So if I go back underneath here, you're gonna notice that I'm in kind of the light blue section. And if I go down to the bottom of the chart right here, there's a 0.7, there's 0.8, and then 0.9 matches my color, okay? Again, on your PDF, you'll get to see this more clearly. So 0.9 is my horsepower correction factor. So I'm gonna go down my spreadsheet and I'm gonna add that right here. So this is 0.9, okay? And then I need to get the basic horsepower for the smaller shiv, okay? Here, what we're gonna do is we need to go to the horsepower rating charts, horsepower rating charts. Now, those are gonna be immediately after the section for the 5V and the 5VXs. I didn't put this number in there, but I'm gonna give it to you right now. And this is gonna be based on whatever the size that you picked. So because we're a 5V, this chart is going to be on page B58. It's gonna be sideways, okay? And then if you tip it, I printed mine off. If you tip it, this is gonna be what we get. So I'll let you get to B58. I think there's a button on the top that you can actually click and it'll rotate it for you if you want to see it horizontal. All right. So now to read this chart, this is for the 5V. Okay, that's going to be the belt that we're looking at. We're going to have the RPM of our faster shaft. That's 1100 or 1200. So I'm taking the 1100 line. Okay. And then I'm going to line it up with the diameter of my smaller shiv, which is 10.9. And I'm going to bring those down and find where they meet. Okay. They meet at 21.3. They meet at 21.3. So that's going to be the horsepower rating for that belt. Okay. That's the basic horsepower. Yes. B58. Everybody there, B58? And again, you might have to click it to rotate it to get it horizontal. The first column is going to be your motor RPM. We have 1160. What was that, Eric? B58. You want to go down to page B58. And this is the horsepower rating chart. You have to look at the bottom of each one of the pages because they have, you said it's page 70, the PDF page 70, but in the catalog, this is their corresponding page, B58, because it's section B. Everybody find this chart? Yes, no? No? Who found it? Jacob did, Adam, okay, you guys found it. Brandon found it, BJ and Eric. Eric, did you find it yet? What numbers am I getting? So I've got the faster RPM, it's going to be down by 1100 on the left. And over to where it's going to intersect with 10.9 at the top. So 21.3 should be your number. I'm doing it right now. Doing it right now. So our basic horsepower is going to be in the chart here. That's the number that we're reading. So you're going to use your RPM of your faster shaft, 1100, and you're going to find where it intersects with 10.9, the smaller shiv. Yes, Dave.
Why don't we just use the 1160 up above that? Yeah, that's right.
1160 above.
The second column down. Yeah, that's what I was.
The second column over here?
No, like, on the second left side, it's like the second one down. They actually have an 1160 down.
Oh my gosh, no, you know what? I didn't even catch that. You're absolutely right. So, oh, it's pretty darn close, but it is a little bit greater. So I am so sorry. You know what? I was reading down here where the numbers were bigger and I just like went right there. Is that what you were noticing, Eric? Were you higher on the chart? I am so sorry. 22.2, which is pretty darn close to 21.3, but we'll put, we'll obviously put 22.2 in our chart, okay? In our chart. That's the basic horsepower. That's going to be this first part. Wow. Light bulb. You would think. That's, I guess, what I was kind of going for. And I kind of noticed that these bigger numbers were down here. So I went right to where the thousands were, but there is some up there. I don't know. Yeah. Yeah. It seems kind of strange. Maybe, I don't know. I won't try to figure it out. So 22.2, we want to put here in our basic horsepower for our smaller shiv, 22.2. There we go. Now there's going to be an add-on horsepower. So we have to go all the way over to the right. Okay, all the way over to the right. We're going to continue on that same line, 1160, 1160. So I'm going to highlight, and then we're going to find our speed ratio at the top. Our speed ratio is 1.72, so it's between 1.58 and 1.94. So we're going to add 1.15. That's going to be our add-on. So go back to our chart, 1.15. Okay. Now, what that did for us, bless you, it calculated what is the horsepower per belt. So that came from adding the two horsepowers together, the basic horsepower and the add-on horsepower for one belt, and then multiplying by that correction factor that we got at the bottom of the chart, based on the color that we were in. Okay. So we added these two together, multiplied it by 0.9, and your horsepower per belt now is 21.15. Okay, that's one belt. Now you'll notice that it's calculating for us how many belts we actually need. All right. So we need 3.5 belts, but obviously we can't have a half of a belt. We have to have an integer number, and the integer number also needs to be a stock value. Okay, a stock value. Now to find what they stock on a shiv where we can line up the grooves, we are going to go back to page B7. Which is, I believe, this one. Okay. B7. You guys are going to find it. Mine are front and back here, some of them. Sorry. Where is my B7? Here it is. Yeah. So here's B7 underneath. Okay. And at the very top here, this was where we saw the different versions of the Super FC or HC. And you'll notice in parentheses underneath here, it says power band belts are available in, bless you, 2, 3, 4, and 5 bands. That's the stock sizes. Okay. So that means we have to pick 2, 3, 4, or 5 because we're going with a stock. And so since we ended up with on our spreadsheet 3.5, then our next stock size up is going to be a 4. Okay. It's going to be a 4. So 4 is going to go here. Now, what this tells us is, number one, we know what sprocket we need to order, or the sprockets we need to order, the small sprocket, the large sprocket. Those were up here. These were the 10.9 and the 18.7. We need to know the belt that we need to order that is going to accomplish the center line of 23.9 that we picked. Now, in actuality, you would have a number for the center line, but we just picked one, okay? Because we weren't given one for our example. So now the last thing we need to do is we need to know, okay, what is the installation take up? So how much do we have to allow for in our design to push one of those sprockets one way or the other to get our belt over the top? And then what do we have to allow for take up or stretch over the life of the belt? So to do that, we're going to have to go to table D33 and D34. And this is going to be on page D29. This is going to be down low because this is going to be section D of that PDF. So D29, I don't know what page on the PDF that is, but it's going to be down far. $297, thank you. So everybody get there.
We download the PDF, and actually type in. Yeah. Or it's really helpful with that.
Oh, if you download it, you can input it. Okay. You can put in D, you can put D29 in. Capital D. Okay, good, good. Oh, the index clickable too. Good, good. I'd just so much rather have a catalog. All right. Yeah.
So view option, two-page viewing, so then we have those charts on both sides.
Yeah.
And then sometimes you have to go to options, just select show cover page, because it might be off by one.
Oh, okay.
You can see.
Kelly just prints hers out. She puts them underneath. Okay, so now on this page, you're going to notice this is going to be where we're going to get our information about installation and take up. So again, the installation is, we need to account for the fact that this is a continuous belt. So we need to move one of those pulleys inward towards the center line so that we can actually get the belt over the top and then push it back. Okay, so the installation consideration is going to come from the chart down here. So what we're going to find is we're going to look for our V-belt number, and our V-belt number was 950. So it's going to fall between 711 and 1160 or 1060. And then we're going to go over to the type of V-belt that we had. We had a 5V, 5VX. So for the Super HC V-belt, not the power band, not the X or the VX, we're going to have 1 inch is going to be our value for installation. And then if we go a little bit further to the very last column, this is going to be the take up. So on our center line, we need to account for installation to the left, if you would, for that, in this case, on this illustration, to the left for the installation. And then additionally, we have to have a way to take it up, and that needs to be 1.5 inches. Okay, so we're going to put those two values into our spreadsheet. So the installation is going to be 1, and then the take up is going to be 1.5. Okay. Now you're going to want to save your spreadsheet because this is going to be for this practice problem. And to finish this up, then down below, you're going to notice that there is a design review. Okay. So instead of going up and labeling where each one of these items is, what I want you to do is I want you to fill the cell here with the reference cell above. So that it automatically populates for you. So for instance, the belt, I'm going to do an equal sign. And then I'm going to go up to the top and I'm going to find, okay, where's my V-belt number? It's going to be the 5V dash 950. That's the one that I filled in when I picked it on the chart. And I'm just going to hit enter. And now it's going to automatically fill in that value. So these are just going to be those equal values. But this lets me know that when you put in the speed of the driver, where is it in the spreadsheet up here? Where am I going to find it? Where is the actual output speed of the driven machine? Okay, and so on, all of these items. So those you're going to fill in to make sure that I know that you know where all the information is for the entire drive. Okay, does that make sense to everybody? Okay, now you'll notice down here, we have our operating center distance and we have the shortest and the longest center distance. The shortest center distance is going to be when you take the center distance that you picked and you subtract off the installation. And then the longest center line is going to be when you take that center line and you add the take up. Okay, so this you have to do a little bit of Excel work, not much. But make sure that you don't just put 1 and 1.5 here. This is going to be the actual shortest and longest center distance. Okay, so this is your practice problem. The first one, or actually the second one, but the first spreadsheet one. And you can take screenshots then when you are all set. Okay, and add that to your practice pages or practice problems document. Any questions before I yes, Eric. says for the speed ratio, it would be the actual. Whole thing. Yeah, I want to see that you have it. Yeah. Other questions? Then I am going to stop the recording. And then we're also, I think it's time for a break.